Okay, everybody, so here we are. We are looking at right triangle division. We're looking at similarity in right triangles. So, what we want to be doing is we're going to start off with our kind of basic right triangle. And what this all stems from is dropping down that altitude of the hypotenuse. So the altitude of the hypotenuse is BD. Now notice that when we drop the altitude of the hypotenuse down, we form two new triangles. And because it's an altitude, there are two right triangles. So we now have triangle ABD and triangle BCD. Okay? And that's going to be congruent to ACB. So what I'm going to do is I'm going to jump forward a little bit and show you what we had up on the board. This is your bow work. You all should have this in your notes. Okay. So here we have the kind of end result when we line all these up. Now notice with the black triangle, the blue triangle, the red triangle, I have flipped them and rotated them so that they're all facing the same way. Okay, so this right here is the right triangle division theorem. When a right triangle, that's the big black triangle, is when you draw the altitude of the hypotenuse, that's B to D, you create two other triangles which are not only similar to each other, that means the blue and the red triangle are similar to each other, but they're also similar to the original black triangle. Okay, so all three of them are similar. Now remember, similar means they are the same shape, different size. So that's really important to remember. So what we end up then with is three different equations. Those are the ones down at the bottom. And those are the corollaries. Okay, first corollary to RTDT, second corollary. Okay, so the first one deals with the altitude of the hypotenuse, that's BD. The second one deals with the red triangle. And the third one deals with the blue triangle. I think I might mix those up a couple times, and if so, I am sorry. I'll fix them as we go. Okay. So, right there, that's the red triangle. A, B, D. Now notice, over here, oops, wrong one. Over here, A is on the left-hand side. On this, it's up top. And that's because in order to get it to match up with the original black triangle, this one right here, we needed to kind of switch things around. We then have our blue triangle. That's the left-hand smaller triangle. And that is part of the second corollary as well. So when we're looking at those two, we are talking about relating legs and the hypotenuse. Okay? And then finally, I circled that one, but really it has to do with the hypotenuse. That's the first corollary. And that's the second corollary. Okay, so let's look at this as a problem. So this is, I believe, number 18 in the book. Do a couple from the book, and then I'm going to do a couple from the worksheet. Hopefully give you a good sample size of all of them. I told all the classes if there was a specific one that you wanted me to do, to email me, and it is currently 10 o'clock Sunday night, and I have received none. No one emailed me, so I picked the ones I wanted to do. Okay. So, that's the altitude, right there. Now notice here, I did the red triangle, and I don't know. See how I did it wrong. So this is actually the blue triangle. Here, let me switch that. Blue. And see, this is blue. See, it's no longer red, it's blue. So we have AD over BD equals BD over CD. Now I know I'm going to flip back and forth a couple times, but I just want to show you that is right here what we're looking at. Okay? AC over CB equals CB over DC. Okay? And that's the altitude one, sorry. AD over BD, this is right here. This is where we find the altitude. So when we do that, the altitude, okay? AD over BD equals BD over CD. AD, that's, if this is A and this is D, AD is 3. BD, that's my altitude, Y, equals Y over CD. Now notice we have the Y bottom of the first, top of the second. That means it is the geometric mean, okay? We then go 3 over Y equals Y over 9. Cross multiply. We get Y squared, that's Y times Y, equals 27. Square root both sides. We get Y because squaring and square root are opposite. So the way we get rid of that square is this square right here. Is we square root. So Y equals the square root of 27. Again, I'm okay with that. If you just want to leave it that way, that's fine with me. However, I'd like you guys to realize that the square root of 27 can be simplified down to 3 radical 3. And that's because 27 is 9 times 3. That means the square root of 27 can be broken down to the square root of 9 times the square root of 3, which is 3 square root of 3. Moving on. I think that this is on the back, 38, I want to say. And again, blue is what I want to do. You know what I just realized? I, over here, did not find X. Okay. So, when we're setting up for X, what we want to do is X is blue. So we're going to go AC over, that's BC equals BC over CD. Okay. So again, what that says is that the leg of the original triangle, BC, that's our X right there, is the geometric mean, that just means it's right here, of the entire original hypotenuse and then that section of the hypotenuse which is next to the leg we're looking for. Our entire hypotenuse, we're not given it, but we can figure it out. We know that AC, we go all the way back to like week 1 in geometry, the segment addition postulate. If we know that A to D is 3 and that D to C is 9, then we know that A to C is 12. We know that BC is X, and we know that CD, we're looking for, there's 9. So that's going to give us X squared equals the square root, or sorry, not the square root yet, just 108. That's 9 times 12. So when we take the square root there, I'm going to actually, again, so we get X equals the square root of 108. I'm okay with that. But a better way to do that would be 6 square root of 3. Okay? And that's because 108 breaks down to 36 times 3. Square root both of them, I get 6 radical 3. Okay. So here, that's where we worked, right? So we're going to go 12 over x plus 3 equals x plus 3 over x. So here we have a lot more x's. And notice it says algebra there, so we're going to use some algebra. we're going to cross multiply, and we get 12x equals x plus 3 times x plus 3. You need to FOIL here. So we have 12x equals, and we get x squared plus 6x plus 9. Subtract 12x from both sides, and we get 0 equals x squared, minus 6x plus 9. Now, we have to factor that out. And again, if you're not familiar with how to factor, come see me at lunch or after school or whatever, and we'll break down the kind of factoring out of x squared minus 6x plus 9. So, when we do that, we get x minus 3 times x minus 3. So when is that true? Well, that's true when x minus 3 equals 0. Add 3 to both sides, we get x equals 3. And that's our answer. Okay, that's it. Now, if we want to ever check this, we can take this right here, plug the 3 back in. So then our triangle would kind of look like this. We know that this right here is 12. We know that this right here is 3, and this right here is 6. So we'd set it up like so. We'd go 12 over 6 equals 6 over 3. Notice that both of those reduce to 2. 2 equals 2. Check. Okay, so that's how you check your work. You go back. You go, is this a blue problem? Is this a red problem? Is this an altitude problem? Plug in your answer back in there. See if it fits. Okay, so this is 39 that we're going to deal with next. Okay, so again, this is a blue problem, and I apologize for the confusion. So we're going to go AC over BC equals BC over CD. So when we sit there and we add up again, we know that AC is going to be 5 plus x. So we go 5 plus x over BC. That's this right here. Remember, the leg is the geometric mean. X plus 2 equals x plus 2 over x. Now, this actually looks more complicated. It actually ends up being easier. So we just really need to kind of slide back into our old algebra selves. Remember how to do this. Cross multiply. So we have x times x plus 5 equals x plus 2 squared. So x times x plus 5, we're going to distribute that x, so we get x squared plus 5x equals x squared plus 4x plus 4. So what I'm going to do is I'm going to subtract x squared from both sides. That gives me, and again, this is not liking me today, is going to give me 5x equals 4x plus 4. Subtract 4x and we get x equals 4. Okay. So again, what the difficult part here is setting this up, realizing it's a blue triangle problem, and moving forward. Okay. Quickly switch over to different. Okay. So here we go. This is, and again, I'm completely backwards, so I write blue there. This is really a red problem for number 1. So this is going to be AC over AB equals AB over AD. So what we're going to do then is just plug everything in. And again, here for AC, we're not given the entire thing, so we have to add it up. 225, that's 81 plus 144. So it gives us 225 over x equals x over 81. X squared equals 225 times 81. Now the reason I'm keeping it like that, if I have my calculator out, I just type in 225 times 81 and then hit the square root button. I don't have my calculator available, so I'm actually just going to kind of break that down as x equals square root of 225 times the square root of 81. That gives me 15 times 9, or 135. Okay, so that's number 1. We're going to go over and look at number 2 now. Again, that is a red problem because it's the left triangle. So here, when I set it up, AC over AB equals AB over AD. So we have 100, that's my AC, that's my entire original hypotenuse, over X equals X over, now here's the thing. We're not actually given what AD is, but we're smart, we can figure it out. We know that from here to here is 64. So we know that the remainder of that is 100 minus 64, or 36. Cross multiply, we get x squared equals 3600. Square root, we get x equals 60. Okay, so again, if any of this isn't making sense, you think you have it, but you're not sure, you're looking at a problem, don't know exactly how I got from point A to point B, go just rewind it. Just go back to the beginning of that slide, rewatch it. So we are now going to do, I have no clue which one we're going to do. Let's find out. 6. So 6 is an altitude problem. See right there? That's our altitude. It's x. So we know that that's an altitude problem. So we're going to go AD over BD equals BD over CD. And again, like the one we just did on number 2, we're not given all of the information here. So we know that that's 36, but we don't know what the other segment is. Now we know that the altitude, BD, is the geometric mean of the two segments. Well, here we're given the entire length of the hypotenuse and one of the segments. So again, we can subtract and get the other one. 64. So that's going to give us 36 over x equals x over 64. Again, if I had a calculator, I'd just type it in and do this. But I know that I have x squared equals 36 times 64. Square root both sides, so I get the square root of 36 times 64. That's going to give me the square root of 36 times the square root of 64. Gives me x equals 6 times 8, or 48. Now, I'm actually going to go ahead and do number 8 next. Okay? Now, number 8, a lot of people had difficulty with because they're like, oh, this doesn't fit. Now, here's the thing, guys. 8 does fit. People said, oh, well, I'm being asked to find this right here, so it is a blue triangle problem. Because I know my blue triangle's over there. Sorry about the yawn, ladies and gents. Not true. What are we being asked to relate here? We're being asked to relate the altitude 60 and the two segments. So this is an altitude problem. The fact that we're used to seeing an altitude problem where we're given the segments and asked to find the altitude doesn't mean we can't do it the other way. We're given the altitude and asked to find one of the segments. So we write out our kind of model formula. AD over BD equals BD over CD. Again, go back to that first slide. Look at it. Know it. Have it written down. Whenever you have to do one of these problems, pull out that note, look at it and go, hey, listen, this is how you set it up. Is this an altitude problem? Is this a red triangle problem or a blue triangle problem? And then write down accordingly the equation that goes with it, the corollary, that proportion that we're dealing with, and then start plugging in the points. Okay, A to D, 25 over 60 equals 60 over x. Cross multiply, 25x equals 3600. Divide both sides by 25, and you get x equals 144. Okay, again, it's completely okay that we're doing this with the altitude being known. Set up the problem the same way. What? Come here, Cleo. Tyra? Okay. The cats are being stupid. I mean, they're cats. They're never stupid. They're just being choosy. Anyway, so last problem. Let's look at number 19. So what I did for number 19 was I rotated it, okay? I rotated it and realized that it is a red triangle problem. See, it's red, not blue. Shush. Okay. So this is AC. Oh, shush you. Hey, Cleo. Not you guys. You guys can be as loud as you want. You're watching a recording. I don't care. Okay. The cats, though. The cats are being loud and obnoxious. So, red triangle. AC over AB equals AB over AD. AC here. Again, we need to add the two together. So notice what I did here. Even though 19's pointing the other way, what I did is actually sketched it and rotated it. If I can't do that kind of video-wise, but if I were you, I would legitimately take my homework paper, take my test prep, take my actual test, and rotate it until it matches up with my model triangle, and go from there. So I have 9 plus x over 15 equals 15 over 9. Cross multiply. 9 times x plus 9 equals 15 squared, or 225. 9x plus 81 equals 225. I'm going to subtract 81 from both sides. And I get 9x equals 144. Divide both sides by 9, and I get x equals 16. So x equals 16. And again, if I want to check that, I'm going to plug in, so 9 plus x, if 9 plus 16 is 25, so that's going to be 25 over 15 equals 15 over 9. See if they reduce the same thing. Hey, Cleo. Okay, 25 over 15, both reducible by 5. We pull a 5 out of each one, and we get 5 over 3. 15 over 9, we can pull a 3 out of each one. And check it out, we get 5 over 3. Is that a true statement? Sure is. That means we did our work right. If you have any other questions, make sure you ask me. Have a wonderful remainder of your weekend, everybody. Let's finish this week strong. Got spring break coming up, so let's really hit the books. And then that way we can enter spring break free from any guilt or worry about what that report card is going to say.